Welcome to SAT TV. I'm pleased to be joined by Ryan Stevenson, Chief Scientist at KYMETA. Thank you for joining me today, Ryan.
Yeah, thanks very much for having me.
Now, KYMETA is a world-leading flat panel satellite terminal manufacturer. Tell me a little bit more about the company's journey and where it is today.
Yeah, absolutely. So we actually started um, in spinning out of a Seattle-based incubator in 2012, and I was fortunate to be one of those founding members that was working the project at the incubator and then helping to start the company. And 2012 through, I would say, 2015 was more of an R&D phase in the company, and there we had to graduate from that phase to become a real product development company. And then a couple of years after that, we had to graduate again and become a company really focused on customer delivery and satisfying our customers, and put a real sales organization together and a real customer service organization together. So it's been a unique experience to at each stage to watch that grow.
Now, you're at the SAT show in Washington. You're announcing the launch of your new terminal, the Kestrel U5.
That's right, yeah.
What's unique about the terminal and why would customers want to buy it?
So the Kestrel U5, it's what we call our third generation technology at KYMETA. It's a pretty dramatic reinvention of the technology. Throughout KYMETA's history, we've always leveraged the display industry and what the display industry is doing with their flat panel manufacturing technologies to make our core component what we call the metasurface. Um, and the U5, the Kestrel U5 is a sort of a reinvention of that. And we're migrating away from liquid crystal, which is something we've used in our previous generations of our technology, to a solid state diode tuning approach, keeping in line with what the display industry is doing with mini LED manufacturing techniques. So that's improved the efficiency of our terminal designs quite a bit. And that's enabling us to go smaller with the terminal. One thing that we've heard quite clearly from customers is that they would like it to be smaller. And so we're very proud to be able to deliver that in the Kestrel U5. The U5 actually defines sort of the aperture area. The terminal itself is actually about 60 centimeters by 60 centimeters square. But this also combines a really unique radome design that you'll see. It sort of has an interesting texture to the surface to help shed water, which is a common issue with all flat panel antennas. If you're flat, you actually can pool water pretty easily. This is a very unique design in the industry that'll help improve efficiency.
Am I right in thinking with this terminal you're branching into high-speed mobility? And what will this bring to, say, for example, the rail industry?
Oh, that's right. One of our first opportunities here is to install in the rail use case. There's a very high reliability requirement there. Rail is a very demanding environment, and the U5 will be able to meet all of those demanding requirements. Um, and the speed is more, I would say, a combination of both the terminal itself and how quickly we can track, as well as then the type of satellite networks that you're operating on. And so within the terminal, we have a very unique tracking algorithm and tracking capability that makes it very well suited to high-speed applications.
Now, production unit expected imminently. How scalable is the manufacturing and can you meet demand across both defense and commercial markets?
Absolutely, we can. The technology is very scalable, and it's one of the reasons why we've aligned the engineering of our core part of our terminal to the display industry. As you and I'm sure all of your listeners are aware, that is a very high volume consumer electronics industry, and as the volume demand for our product grows, we have that industry to leverage in a sense, or to ride on their coattails. So scalability really for us won't really be a challenge.
Okay. Now, You had some exciting news last year with the announcement of the breakthrough, the ability to simultaneously switch from KU band and KA band from one antenna. Where are you with that development?
Yeah, that development is progressing. We recently announced a partnership with Japan Display. Um, they will be our partner going forward to um, develop the full scale aperture size. Again, keeping in line with what I said earlier about partnering with the display industry to manufacture the meta surface. Um, and so that the focus of that partnership is to produce the commercial version of what we will launch as a product, likely in the mid 27 timeframe.
Okay. Explain a little bit more about what it's going to mean for the industry and what benefits it's going to bring to the end user.
Absolutely. Well, as I'm sure you're familiar and your listeners are familiar, there's a lot of KU band satellite communications capacity, both in legacy GEO and LEO, obviously with Starlink and OneWeb. And we'll have the same in Ka band as well, with the legacy GEOs, the MEOs, and Amazon LEO coming online here pretty soon. Um, but right now, there's no common piece of user equipment that will interoperate across those bands, or in a lot of cases even across those different orbits. Um, there are unique phased array designs like the the Amazon LEO phased array design or the Starlink phased array design that are intended to work on their own LEO constellations. But there's a lot of additional requirements required from the antenna to be able to operate across the different orbits and then operate across those different bands. KYMETA's, we can do this, frankly, like no other antenna design on the market, being able to incorporate all of this capability in one physical aperture and then operate on these different bands simultaneously. So we really think about it like when the terrestrial cellular industry emerged out of the 3G paradigm, where you were worried about a GSM standard or a CDMA standard, and would my phone work in Europe or wherever it would work. And then eventually through standardization, now you have a common piece of user equipment that can operate globally. Our vision for our KUKA technology is the same. We will have a common piece of user equipment that can operate across any of these networks.
Now, do you already have customers lined up for this new tech?
We do. Um, um, I'm not sure, mostly on the military and Department of Defense side of things, so I can't say too much about that. But we absolutely have actually a first customer lined up to start testing early prototypes of this next generation full size aperture.
Okay. And I understand, congratulations. I should be awarding you congratulations for being inducted into the class of 2026 for the Space and Satellite Professionals International. What does that mean? What's it like to get an award like that?
Well, first, thank you very, very much, and is I would say honored and flattered by that award as I am. I also have to mention that I've been very privileged throughout my career with KYMETA to have a phenomenal team working with me, and you know their dedication day in and day out. It's is a much a complete team award as it is my award. But it really is an honor. The SSPI, for a little over 40 years has been a leading organization within our industry, and to be included in the same mention as the luminaries that are in their Hall of Fame, like obviously Arthur C. Clarke is there. It's really quite incredible and humbling.
Brilliant. Well, congratulations on that. And Ryan, thank you for joining us today.
Well, thank you very much, Richard. Really appreciate it.